Transformation style. Transformation style. Reflection, translation, rotation, transformation style. Reflection, translation, rotation, on a man trying very, very hard to dance, flipping upside down. Then it's a reflection, spinning round. 3, 3, 6, 360 degrees, that's a rotation. Slide the guy, sliding 2 units to the right. You slide the guy, 3 units up, I tell you. Slide the guy, that's called the translation. A flip a spin, slide now, in a rotation. It's a reflection, and slide, there's a translation. If you speak, it's a rotation. Transformation style. Transformation style.
Well, here we are, geometry students, to our last lesson in chapter 4 on the transformations. We're looking at similarity and transformations. So we're going to be performing similarity transformations. So that would involve all of the different transformations that we've done, which is translations, reflexive rotations, and even dilations as well. All right, before we get into that, let's do a little cartoon. So here's one. It says, "A costume I have, scary I am. I wonder who's underneath the ghost costume." Gonna have to use that voice to say that. Costume I have, scary I am. Something like that. I don't think he really needs a costume, honestly. All right, well, let's get into our vocabulary. So on page 119, here's the vocabulary for similarity transformation, which you can write there for that vocabulary. It's just that it is a dilation or a composition of rigid motions and dilations. So a dilation does change the size. It can enlarge it or it can, reduce it. But that keeps it similar, though, because it doesn't change the angle measures of the figure. It just really can change the the sides of that shape, but it still keeps it similar shape of that figure. So here's what it says here for similar figures. Two geometric figures are similar figures if and only if there is a similarity transformation that maps one figure onto the other. So a similar figure would be able to have, we can do a similarity transformation, which would be either using a dilation or the rigid motions, which is there's our 3, the translation, reflection, and rotations are the rigid motion ones. Then we would have similar figures. So go ahead and copy those down there in your notes on page 119 for those two vocabulary words. Okay, so here's what we're talking about with the similarity transformation. Again, we're going to be given a original figure here with triangle ABC. Those are our original points. We're going to do a composition, so we'll do a translation first, then a dilation. And so the first thing to do is just to plot these points on the graph. So what's what we're doing, we're plotting the original points. Then we're going to do the translation from these, which means we're going to say x plus 5. We're going to move them 5 units. So all the points are going to move 5 units to the right and 1 unit up. If you were to plug all these points in, x plus 5, y plus 1 is what we would get for those points. When you do that, you move it 5 right and 1 up. We get now this same exact size, but then it says to do a dilation. And your scale factor here is 2 because you're multiplying the x and the y by 2. And so if we do that for all of these points in red now, multiply all of them by 2, so 1 times 2, 2 times 2, and so on, we're going to get a much bigger figure. It'll now change to this figure up here. So that would give us, multiply these by 2, you get 2, 4. These ones times 2 is 6, 4, and both the 3's will become 2 6's here. And so now there's our final ending point with A, B, C double primes. So that's what we're trying to do on our first few problems in the extra practice. So let's go on to that. All right, so here on page 120, we're looking at to graph the polygon with the given vertices and its image after the similarity transformation. So we're going to first plot these points, the original figure. It's got 4 points, so it's going to be a quadrilateral. And so let's go ahead and plot those. You can go ahead and pause the video and just plot those pretty quickly and then play it. So if you do that right now, what you should see now is 36254355 becomes over here. So here's our original. Okay, now we're going to do a translation. So we're going to be plugging all of these numbers in, all the x numbers, and then subtracting 5 from them, and all the y numbers, we're going to subtract 3 from them. Or you could just, you could also move the points, but let's go and write down the new points just so we have them as well. We're going to basically move it 5 units to the left and 3 units down for all of these points. All these vertices will do that. So for the a prime, it'll be now -2, 3. So that's just being, putting 3 here. 3 minus 5 is -2. 6 minus 3 is 3, and so on. For the b prime point, it's going to be -3, 2 when we subtract 5 from x and subtract 3 from y, and so on. So then our c prime is -1, 0, and our d prime is 0, 2. Okay, so that's what you've just done. You've gotten those points. Go ahead and plot those also on the graph. So now that made a translation. It's still all the same exact shape. It's a rigid motion. It just moved left 5 units and down 3 units for all of these points. You can even just see like C right here. Left 5 puts you here, down 3 is right there. It maps right on top of itself. Then it says to do a dilation, which is your scale factor here is 3. We're going to multiply the x by 3 and the y by 3. Let's go ahead and use these points. This is kind of why I wanted to get this. So we can kind of just do one step at a time. So now we can see these ordered pairs and then just multiply by 3. And I think that's going to be a lot easier to do the dilation. Yeah, we could have just done this on the graph, but if you have your points, then you actually can see the numbers you have to multiply by 3. So 3 times -2, 3 times 3, that now gives us a -6 and a 9 for our a double prime. -3 times 3 and 2 times 3, so it's going to be -9, 6. And -1 times 3, 0 times 3, it's going to be -3, 0. And then 0, 2 becomes 0, 6. And so now we just plot all 4 of these points on here, and our shape now should get bigger than this because it increased by 3. It's a scale factor greater than 1, so it is going to enlarge. And so our enlargement should be like that right there. And so that's what you should have now on your paper. Make sure you draw these on your paper as well as put your points down like this. Okay, so for number 2, go ahead and start with just plotting the points. We have 3 points. We have a triangle, RST. Go ahead and plot the points RST right there on your graph. You can go ahead and pause the video and do that part. So after you've plotted your points, your triangle should look like this. It's a fairly large triangle. And our first thing to do is a dilation. And the 1/4, since it's less than 1, means it's going to shrink this triangle down by a factor of 1/4. And so also, if you think of it as if it's 1/4, multiplying by 1/4 is the same as dividing by 4. So it may be easier to think about. We're going to divide all of our x and y numbers up here by 4 to get new points. So our new r prime, I should say. So new r prime is going to be 3, 2, because we're going to divide this by 4. 12 divided by 4, 8 divided by 4 gives us the 3 and the 2. For s prime, that's going to give us a 2, 0. So we get 8 divided by 4, 0 divided by 4, still 0 there. And for t prime, we get 0, 1. So 0 is still 0, 4 divided by 4 is a 1. And let's go ahead and now plot these points over on your graph. I'll give you a second to do that. Plot those points. Alright, so once you've plotted the r, s, and t prime points, now your figure got smaller. It looks like this here now. So it's definitely shrunk. It reduced down to these little smaller triangle. And now we're going to take that triangle and do one more thing to it. We're going to reflect this triangle now in the y-axis. So we are going to flip it over the y-axis. And if you remember, there is the coordinate rule for that. That might help us. I mean, you don't have to. You could probably do it manually. This point right on the y, if it's touching the axis of symmetry or the line of reflection, it's going to be that same point. R is 3 units this way, so 3 units that way we'll put there. And then S will be 2 units. But if you do remember for the coordinate rule, that coordinate rule is you're just going to change the x to their opposites, y will stay all the same. And so if we did that for our 3 points here, here's our points, the actual points would just be changing x to the opposites. These two will be negative. 0 still is going to be 0 here though. So that's why at -3, 2. for s double prime negative 2, 0, and then this t is exactly the same. Like I said, that's not going to change. We're going to stay right there since it's already on the line of reflection. And so now your new triangle, just plot those points, and we're done with this one. There's our final triangle. That is what they asked for. We're graphing the polygon, which is the original one, and the image after the similarity transformation. So it's really this one here and then this one here. We like to get this middle one just so we can get the idea of how to get to this one. For that green one, that's the last one. Okay, so for problem 3, we have an x, y, z, so you want to first plot those points. Go ahead and do that. Plot x, y, and z on the coordinate plane it gives you. All right, hopefully you've done that. You pause the video and you've done that. It should look like this. X, y, and z, the triangle is over there. First is to do a rotation 90 degrees about the origin. So this one definitely we would like to see a coordinate rule for this one because it's going to be a lot harder to remember how to do it maybe just by manually. I mean, we can do it manually, but it might be easier to just know what that coordinate rule is. Remember, you go back to page 105 in your notes, and that's where you'd find it. It is this, negative b and a. Remember, b is like y, so it's basically opposite of y first, and then the x is next. So we do have to flip our numbers here, but the y number, as we flip it, like this 6 here, is going to become negative up front, and 9 will be behind it. So that's what we'll see for our first one. For the x prime, negative 6 up here, 9's behind it. This one, they're both 3's. So if we flip it, that doesn't do anything, but we're going to make this first 3 negative. So it'll be negative 3 and a positive 3 for the y prime. For this one, when we flip it, 6 will go up front, and it will become a negative 6 up front. 3 will be positive 3 in the back. And so now we just plot these points here. So go ahead and do that. You'll plot those points after that first rotation. All right, hopefully we plotted those, and now it should look like this for the rotation. It's now still the same size, but now we are going to change the size with the dilation. And the dilation says 2/3 times x, 2/3 times y. So 2/3 is your scale factor, so it's less than 1. We are going to make this smaller then. This will shrink or reduce. And so when you multiply each of these by a 2/3, you could, I would just keep multiplying it by the fraction, but you can multiply the number by 2 and then divide by 3. That might be easier to think of. So like right here with negative 6 times 2 is negative 12, and then negative 12 divided by 3 would be a negative 4. So you can see we're going to get negative 4 first. Here, the next one is 6 because 9 times 2 is 18, and 18 divided by 3 is 6. So negative 4 is 6 for that one. This one, negative 3 times 2 is negative 6, and negative 6 divided by 3 will be negative 2 first. And then it'll just be a positive 2 second, since it's just a positive number there. So it'll be a 6 divided by 3. And this one, again, negative 6, just like this one's going to be a negative 4. 3, just like this one, will be 2. So negative 4, 2 for the z double prime. And now we just got to plot these points. Go ahead and plot these points, and then we'll be done with this one. All right, so our final triangle should look like this right here. So it just got a little smaller. Here's our points in here. So you got your x is actually up on top here. Did I do it there? No, didn't do that there. So no, I guess I must not put the x up there. That's the x double prime up there. I should probably put that. My green is going to be a little bit different, but there's our x double prime right there at negative 4 and 6. And then negative 2 and 2 is the y double prime. Negative 4 and 2 is our z double prime right there. All right, so let's go ahead and do a little quick joke of our day. So here we go. What did one toilet roll say to the other toilet roll? He said, "People keep ripping me off." That's a good joke. People keep ripping me off. That would be true. Okay, so on page 121, back to the extra practice. So this 4 through 6 is kind of just doing it backwards than what we just did. It's not giving us the transformations. It's wanting us to describe those similarity transformations. It gives us the actual shapes on our coordinate plane, and we got to figure out, okay, what did we do to go from the pre-image to the image? So remember, the pre-image is your original, and the image is the new figure. And so we know the original one, the pre-image, is just these points there, like this one. We got L, M, and N. So that would be our original one. The prime points here would be the new one, the image. So what did we do to go from here to here? Well, first of all, you want to see that, well, the shape got smaller. It got reduced. So there's a dilation to be done. So the first thing is there's a dilation. And what did we do with X and Y? What did we multiply X and Y by to get from this size to this size? And you can just look at really one side length. If you just look at from M to N right here, it is 2, and now the new one is just 1. So it got multiplied by a half. That's half the size. So that means our scale factor would be a half. This would be our coordinate rule, 1/2 times X, 1/2 times Y. So that's what we would do there. And so let's go ahead and do that first to these points. So we're going to do that to these points. So if you think about the points here for this, you got M is 0 and 4. So if you multiply 0 by a half, it's still going to be 0. But then you multiply 4 by a half, well, now that's 2. Same thing for N. It's going to be still 0 here for N, but it's 6. Now it's going to be 3. Over here for L, on this side, we got 6. For X, well, now that's going to be halfway. That's going to be 3. And it's also 6 here, so it's going to be like a 3, 3. So you just kind of shrink your points down from this. And now we're here. So that's where we are. So we're at 4 here. Now we're at 2. We were at 6 here. Now we're at 3. This one now was at 6. Now it's going to be at 3 this way. And we were at, or I should say it was at 6 on the Y. Now we're at 3 here. It was 6 on the X. Now we're 3 here. And so now that's the same size and shape as what we have here. So now the last thing would be just you can see it's just going to be a translation. We're just going to move it right and down. So we do a translation for this. We can just go off of that first one, this corner point here, which would be the L prime one. If we figure out, okay, how far do we go to the right? 1, 2, 3, 4. So we're going to say X plus 4 for that rule. And then down 1, so Y minus 1 for that rule. So our translation would be X plus 4 and a Y minus 1. That's our answer for this one, stating the dilation and the translation. Okay, for number 5, same thing. We see that the smaller one here is our original. The bigger one is the new one. So first of all, it got larger. That's the one thing to notice. There's a dilation. So we got to figure out what dilation is going to be here. What is our coordinate rule? What are we going to multiply the X and the Y by in this dilation? The original from B to C is 2. And now from B to C prime, it's 4. So that means we multiplied 2 by 2 to get 4. So our coordinate rule can just be this, 2x and 2y. We're going to multiply it by 2 to get to the same size as our new one. So if we just multiply all these by 2, so the C right here, which is -1 and 1, that's now going to be -2 and 2. It's going to be right up there. This B right here, which is at -3, and 1 is now going to be -6 and 2. The A here, which is at -3, that's now going to be at -6 also. And the Y here was at 3, so now it's going to be -6 and 6. Going up there. So that's going to be what the size is now. It should look exactly the same size as our new one on this side. And now we got to figure, okay, what did we do from here to here? We didn't just move it. We didn't just translate it like we did on this one. This one, you could see that it has flipped. Looks like it's flipped over the y-axis. That would be a reflection. You can see this point right here is exactly 2 to the left of the y-axis. This one here is 2 to the right. So they're all exactly the same distance away from the y-axis, so it's a reflection in the y-axis. That's what we would say for our second transformation. So that's our answer for this one. There's a dilation of this rule and a reflection in the y-axis. Okay, so here's our last problem, number 6. We're doing essentially the same thing, so we need to see that the original is the bigger one right here. This like parallelogram really is what we would call this. Smaller one is the new one. So we need to reduce it down. And so we want to notice, okay, let's look at a side length where we can clearly see it, like right here from T to Q, that is 3, and from T to Q here it's 1. So it shrunk down. We basically divided it by 3, which is a 1/3. So it is a dilation. The dilation there is a 1/3 times x, so 1/3 times y, or you can just be dividing the points by 3. So let's actually put the points down on this one, and that might be helpful for you to always do that. I didn't do that on the last two, but maybe we should have. But on this one, let's go ahead and put these points down. So for all the points here on the bigger one, we got an R here is 4, 3. We have S right up here at 4, 6. We have T right here at 0, 3. And I'm not going to put Q because Q is 0, 0. No matter what we do to 0, 0, unless we're going to translate it, we're not going to change that. You can see here it's still at 0, 0 for even the Q prime point. So I'm not going to include that one, but these 3 points are definitely going to be changing. So for this one, I'm going to multiply each of these by a 1/3 or divide them by 3. So first of all, 4 times 1/3 would be like 4/3 or a 1 1/3. And then 3 divided by 3 is 1. This one, again, we're going to get the same thing, 1 1/3. And then 6 divided by 3 is 2. Here, 0 is still going to be 0, but 3 divided by 3 is 1. So 0, 1 for that one. And so now if we plot these points, so I think about where 1 and then 1/3 might be, and then 1, it's going to be kind of somewhere up in this neighborhood right here. So you can see that's where my R is now. My S is going to be 1 1/3 again, but then up 2, so right about in that spot right there. 0, 1 is just right here. So there's our one after the first dilation that's being done to get it down to the same size as our new one here for the prime. And then as you can see, we're not reflecting it. If I reflect it, that wouldn't work because my S prime would be over here on this side. So it's not a reflection. What it is, it looks like it's a rotation. So if you see, this would be my T and my Q. T now comes down to here. Oops. So T is coming down to here, S is coming down over to here, R is moving over. So it looks like it's a rotation of 90 degrees, and that would be in the direction counterclockwise about the origin. So 90 degrees rotation, 90 degrees about the origin. I should have said counterclockwise as well on this one. So let's put also counterclockwise. So that's so you should put that down as well, counterclockwise, counterclock. All right, so we'll put counterclockwise on this one because that's the direction that we're going. Clockwise would be the other direction this way. All right, so that concludes our lesson here on the 4.6 and concludes our lessons on Chapter 4. So I will see you then in Chapter 5.